Hello guys, welcome to my YouTube channel. In this video, I will talk something about clustering. So this clustering technique falls under a category of unsupervised machine learning class of problems. When I say unsupervised machine learning, we do not have any labeled data to classify or predict our given set of data points. Okay, so we have to identify some patterns within the given data points and group the related data points together. Okay, so for example, let's consider I have listed some things here, right? So mobile phone, protective case, charger, headphones, earbuds, etc. So these all are related products, so we can classify them under one cluster. Maybe we can call it as cluster 1. Okay, so this can be our cluster 1. So similarly, we have notebooks, papers, pens, pencil, eraser, etc. So these are all related products, we can classify or group together under our cluster 2. Okay, and similarly we have other products which are shoes, sandals, socks, slippers, etc. So these all can be grouped together and we can call it as our cluster 3, right? And here is a typical clustering example. When I say news, there can be different categories, right? Politics, so all the politics related news can be clustered together, grouped together, and politics can be our one cluster, right? And similarly, all the weather related information can be grouped together and we call that cluster, we can call that cluster as a weather cluster. Similarly, if there are any religious news coming up, we can group all of them together into one place and call that cluster as a religion cluster. And similarly, all the sporting events, all the news related to sports, whichever sports may be, we can group together and call it as a sports cluster. So like this, when we have a given set of data points without any labeled data, we have to find similar data points which are related to each other and then group them together into different clusters, right? So these are our one set of data points here, we have grouped them in one cluster. These are different second set of data points, we have grouped them into another cluster. So similarly, we have to go on grouping them, right? So in this particular case, I am going to talk about something called as k-means clustering. Okay, so k-means clustering, there is no expansion for this k-means as such. So here k stands for the number of clusters. Okay, this is capital K, this is expanded, or we can understand this as number of clusters. So given m data points, okay, if we have m data points with us, we have to group these m data points into this k clusters. Okay, this k can be anything, 2, 3, up to capital K, this can be any number. So in this case, if we consider these three set of categories, we have k is equal to 3. Okay, so we have 3 clusters here, so this capital K will be equal to 3. So this is what k in k-means stands for. Now there are some steps which k-means clustering follows. So I will list them here one by one. So the first step is, given a set of data points, so we will be given a set of data points, right? So once we have the set of data points, we will randomly initialize k clusters. Okay, k clusters, these are also called as cluster centroids. So remember this guys, this is going to be very important term, and whatever steps I tell which follows it are really important. So these are also called as cluster centroids. Okay, and then once we have randomly initialized the cluster centroids, k cluster centroids, the second step is we have to assign data points to these k clusters. Correct? So how we are going to assign it, I will explain it. So this is called as cluster assignment step. Okay, so this step is called cluster assignment. And then in the third step, we will move the cluster centroids. Move cluster centroids. So I will tell you in detail what do we mean by this. Okay. Now, once we have initialized randomly the k number of clusters, the two most important steps are this. One is cluster assignment and another is moving the cluster centroids. So I will talk about these two important steps in detail now. Okay. So the step cluster assignment, right? So I will just name it as cluster assignment. So after initializing the k clusters, once we have the data points given with us, we will randomly initialize k clusters. Now for m examples, for m data points that we have with us, we will compute the distance. So compute the distance for each of the m data points, right? We have m data points, correct? So compute the distance for each of these m points with k clusters, correct? So what we are doing in this step, in the cluster assignment step, first we will consider all the m data points. We will compute the distance between each of the m data points with each of the cluster or cluster centroids, right? Then what we do, we will assign the data points to the cluster. Assign the data points to our cluster centroids. So how do we assign this? We will assign the data points that are close to whichever cluster centroids that we have calculated in this particular sub step, right? So let's say, as an example, we have a data point here, and this is one cluster centroid, this is another cluster centroid that we have initialized randomly. So what we do with this step, we will calculate the distance of this data point between k1 and this data point. Also, we will calculate the distance between this data point and k2. So let's call this as d1 and d2. So if d1 is less than d2, we will assign this data point to k1. If d2 is less than d1, we will assign this data point to k2, right? So in this way, once we complete assignment step, assigning the data points to each cluster centroids, let's say in this case, for an example, we have initialized k is equal to 3, so that we want to have 3 clusters in our given data set. So what happens, each of these clusters k1, k2 and k3 will have some data points assigned with them, right? So let's call x1 is assigned to cluster centroid 1, x3, x4 and x10. So let's say these things are assigned to k1. So similarly, we can say x2, x6 and x7 are assigned to cluster centroid 2, right? So these are the data points x1, x2, x3, x4 and these are all data points representation, okay? So in k3, in the third centroid, we have x5, x8 and x9, okay? So in the first cluster centroid, we have 4 data points assigned. In the second cluster centroid, we have 3 data points assigned. In the third cluster centroid, we have 3 more data points assigned to them. So now this cluster assignment step is completed. Now we go ahead and look at what is this move centroid step deals with. Move centroids. So with the data points assigned to each clusters, we will calculate the mean. So for example, for k1 cluster, we have these data points assigned, right? x1, x3, x4 and x10, correct? So we will compute its mean. So how do we compute its mean? So we have 4 data points, 1 divided by 4, summation I is equal to, so we cannot generalize this, correct? So we have to add up the data points x1 plus x3 plus x4 plus x10. So this is how we calculate the mean. Now whatever the value we get, the average value here, right? So the average or mean value this new mean value will be treated as K1. So that from this K1, we have moved successfully to the mean value of the data points assigned to that particular K1 earlier as our new cluster centroid, right? We do this for all the randomly initialized K cluster centroids, okay? So these are the two important steps in K-means clustering, right? So what we do and how many times we do, we repeat this cluster assignment and move centroid steps multiple times till the time we see that the cluster centroids are not moving any further. So as an example, if I can plot something for you guys, let's say after moving certain number of times, assigning the data points to clusters and moving the centroids several times, let's say we arrive at some grouping of the data. Okay, so this red here is our one cluster centroid, one cluster, and this yellow here can be treated as another cluster centroid with these data points assigned to this particular centroid. Now, after assignment, if we calculate the mean value of the data points, we will again get the same as this particular cluster centroids, right? So let's call it as K1 and K2. So in this case, when there is no further movement of the cluster centroids, we will stop the process. At this point, we would have achieved a perfect clustering of our given data points. Okay. Now we will see the algorithm in more formal way. So hope you guys understood this. If you guys have any questions till now, you can post it in comment section. I will get back to you with the answers. Okay. So now if I want to write algorithm in a more formal and mathematical way, I will write it like this. It goes something like this. Okay. So as usual, our first step is always to initialize the cluster centroids, right? Randomly initialize K cluster centroids, and we represent this or denote it with the help of mu1, mu2 up to mu k, right? So these are our initial K random cluster centroids. Now after initializing, we will repeat our cluster assignment and move centroid steps, correct? So what do we repeat here? So we have m data points for I equal to 1 to m. What we do? We will index, right? Index from 1 to k. These are the index of cluster centroids, correct? Cluster centroids for xi. So for each data point, we will assign a cluster index, and that is denoted as ci, right? For example, let's say we have x1, x2 and up to xm. So these are our data points, and we have initialized k equal to 3, so that we have mu1, mu2 and mu3 cluster centroids. Okay. Now if c1 is equal to 2, this means that x1 is assigned to mu2. Okay. If c2 is equal to 1, this means that second example or second data point is assigned to mu1. So mu's are our cluster centroids and xi's are our data points. So like this, if cm is equal to 3, it means that mth training example is assigned to third cluster centroid, that is mu3. So this is what this ci represents. Okay. So this is our cluster assignment step, right? So now we are done with cluster assignment step. We have to move the cluster centroids. So for that, we have to run a loop for k is equal to 1 to capital K. So note, it's a small k. We are going from first cluster centroid till k cluster centroids. In this case, we have 3 cluster centroids, correct? So what we do? We will move this is again small k, mu k is equal to average of the data points assigned to kth cluster centroid. Okay, so this is how we can write a more mathematical way the k-means clustering algorithm. Okay, now you might get a question such that what if a randomly initialized cluster centroids initially gets 0 data points assigned to it? So what happens? So let's say mu3 in our case gets 0 data points. So how do we deal with this kind of scenario? So there are two ways to deal with it. The first one is either we reduce the number of clusters by 1, that is we go with k minus 1 clusters, and initially we will go with k minus 1 cluster centroids. Okay, so this can be one way, or the second way could be randomly reinitialize, right? Randomly reinitialize the cluster centroids, right? Cluster centroids, CC for cluster centroids. So in these two ways, either of this way, we can reinitialize or reduce the number of clusters if we get 0 data points in any one of the clusters. So more specifically, we will go with this particular step, but if we want to stick with, if we are sure that these data points have these many clusters, we will go with random reinitialization of the cluster centroids. Okay, so that's it for this particular video. Please remember these notations here, because in my next video I am going to talk about the optimization objective of this k-means clustering, how we can come to know that we have reached a global minima in this, and also I will talk about how we can select the number of clusters if we do not know the number of clusters beforehand going to implement this. Okay, so please post your questions in comment section. Till we see in the next video. Thanks one and all. Bye bye.